Okay, second example and last example for the day is that second data file that I had posted on my website. And so what this data is I asked Zhenghua Li, so she's in the computer science department. She specializes in high performance computing. So this is a high performance computing class. So one of her high performance computing classes, they had done some kind of project that generated a whole bunch of data. So I asked her, can you give me a data file that we could just practice with? And so this is what she gave me. And so I don't understand exactly where it came from, but what the data file is showing, and as soon as we open it up, I'll point out what I mean, is the computer was running a number of processes, and the data file recorded two pieces of information, like at what time the process ran and how long it took. So the first column is just sort of an increasing list of numbers because that's the time that the process ran. And so like when it comes to the next one, it always ran at a later time. So it's not recorded in like hours and minutes. It's in some kind of computer processing time just for how long the process was running. The second column looks like a list of random numbers. That's the data we actually want to investigate. So that's how long that particular process took to run. So we're going to find a 99% confidence interval for processing time in this data file, this second data file. So let's flip over to menu tab and upload our second data file. So open the computer data, compute comma separated value file. So this does have a column header, not on the first one, but on the processing time column. So we're going to say data has column names, and everything else is set up okay. So like I mentioned, this first column here is just a list of increasing numbers because it's a time when that particular process ran. And then these numbers on the right are sort of a list of almost random scene numbers, lots of single digits, a couple in the 10s and 20s, but basically just a list of like random seeming numbers. And there's a lot of them. This goes down to like 10,000. Okay, so this is a pretty big data file, much bigger than the ones we've been using so far normally. But so even though I have no idea what the project was that they were doing that generated these numbers, I can still run a 99% confidence interval. Just eyeballing it, it looks like the average is probably in like the middle single digits, like 5, 6, 7. There's are a lot of ones in here, but there's also some like 15s and 20s that would pull up the average. So I'm guessing something around 5 or 6, probably single digits, but I don't really know. And because there's 10,000 data points, the 99% confidence interval should be pretty narrow. Like with that much data, we should be quite confident that our guess is accurate. So let's see what we get. So one sample T, not exam 2 anymore. Let's get rid of that. We're going to use this process time, and we're not doing a hypothesis test. I know nothing about this data, so we have no number to compare to for a hypothesis test. I do want to do a 99% confidence interval, so we'll change the confidence level to 99 under options. And this probably still has histogram under graphs. Let's keep that histogram. Let's see what it is. Okay. Speaking of which, under graphs, box plot. I don't think I ever talked about box plot, but that basically puts the quartile. It tells you what the quartiles are. So it draws a picture which tells you where the median and the quartiles and the min and the max, the lowest and highest number are. So you sort of have like these 5 spots on the graph that show you the min and the max and the first and third quartile and the median in the middle. And it's basically a graph version of the quartile way of summarizing information. Stats people like to use it sometimes, and it shows up sometimes in graphs you might see on websites to summarize data. but I don't really like it, so I don't use it very much. Individual value plot probably has a little dot for all 10,000 of these. Maybe we could try that, actually. I'm going to check this individual value plot. I want to see what it looks like. So we'll get a histogram and an individual value plot for this. So let's see OK and see what happens. So our mean came out just under 5. Okay, so my guess of single digits looks like it worked and pretty close to 5. Like I said, 10,000 data points. And our 99% confidence interval is still very close to 5. So we're pretty sure that if we ran this a million times, we would still get a mean very close to 5. So like between 4.8 and 5.01 or 5.06. Okay, so notice that the standard deviation here is pretty big. It's like 4 because there was lots of 1s and lots of 15s and 20s. That doesn't mean that 99% of the data was between 4.8 and 5. It means that we're pretty sure that the mean is between 4.8 and 5. The data is all over the place, but the highs and lows balance out, and the mean end up in here. Okay, let's see what our graphs look like. Here's our histogram. Okay, so it's just like a nice decaying exponential thing. So maybe this process time is determined by an exponential distribution. Looks like an exponential graph, so perhaps it's an exponential distribution. I suppose that maybe that makes sense if we knew what kind of experiment they were running, that it would be an exponential. And here's our individual value plot. Basically, there's a whole bunch of 1s. It looks like there was 1,394 1s and 239 2s and 1,063s. So I don't know why they didn't make these like bigger to adjust, but maybe they just wanted to make it so that you could see these other ones that like were less common. Okay. Oh, so these are a bunch of dots. Like you can see here, there's 1 dot here, and there's 2 dots here, and there's 1 dot, 1 dot, 2 dots, 3 dots. So the problem is that there's like a gazillion dots all piled onto each other, and we can't really see what's going on. So this would probably be a better graph if we didn't have 10,000 data points. Maybe once we're done with this example, I'll flip back to the exam one, and we'll do this dot plot, and then we can see what it means. All right, but what we wanted out of this was the confidence interval, and it looks like it's very close to our guess because we have so much good data. Okay, I'm going to rerun this graph on exam 2. Okay, I have to flip this over to our exam data. I'm going to rerun this graph on exam 2 so that I can see what that individual value plot looks like when you don't have 10,000 dots running around. Okay, so exam 2, let's see what we get here. Okay, so that's a little better. So each of these dots represents some student's exam. So there's one person who got 50, one person who got 49, and I think there's 4 tiny dots there at 48, and 1 at 47, and 3 tiny dots at 46. When you see a pile of dots, that means a bunch of people got that score. So there is a bunch in here, and a bunch in here, and a bunch up here, and it kind of goes up, down, up, down, up, down. Now, I don't know that there's a pattern in that, though. There's only like 54 students. But basically, there's a dot for every single student. And here, when there's only 54, maybe that actually means something. When there was 10,000, they were all piled on top of each other, and we couldn't really see what was going on. So in general, I guess I like the histogram better. That's easier to see. These dots were hard to interpret. So histogram is going to be my go-to for graphs. All right, so I think that's it for today. And then next day, we'll move on to the test that we should have used for exam 2, which is comparing 2 sets of data in a confidence interval or hypothesis test. All right, that's it for today.